This is the conceptual, a conceptual argument against design. It was first proposed by Professor John MacDonald at the University of Delaware, and it has to do with the concept of irreducible complexity. Just about the day that my book came out in 1996, people were trying to see how they could build mousetraps by numerous successive slight modifications. That's a good thing to do. That's how you would attack an argument like mine. And for my money, the best one was put out by this fellow, Professor John MacDonald. And he wrote on his website, which is shown up there, he showed this trap, and he said, well, this Behe guy, he said, this is irreducibly complex. It has all these 5 parts. You take one away, it won't work. He says, but I can take away a part, and it'll work. I can take away the catch right here. He says, I took it away, and now I put the holding bar down here, and it's just kind of tucked into the edge of the hammer. And the idea is that if a mouse comes along, this is just precariously balanced. He nibbles the cheese, this will slam shut. If the mouse is unfortunate, maybe his tail will be hanging over here. This will catch the tail. He'll have to drag the trap around behind him. You won't be able to get food as efficiently. You won't be able to attract mates. And it would work. It might be a little less efficient, but it would work. But he continued, not only that, I can take away another part, he said. I can take away the holding bar, and it will still work. He says, look, I took away the holding bar, and now the hammer is shaped so that it's just touching the edge here, and the tension is pushing it down. Again, the idea is the mouse comes along, nibbles here, this goes over the edge, this snaps down and catches a paw or a tail, and the mouse is in trouble. But he said, I can build a trap with 2 parts. I can take away the hammer. Now the spring itself is shaped so that it hangs precariously by the edge here, and the same thing, if the mouse came along and nibbled, it might get trapped. But he said, yes, indeed, I can build a mousetrap with 1 part. And here it is. This is the one end of the mousetrap, precariously balanced on this one, and it's under tension so that if it's released, this will go down, catch a paw or a tail here, and again, the mouse is in trouble. So he's saying that, yes, I showed a mousetrap with 5 parts, he can make one with 1 part. But nonetheless, he says something strange on his website. He says, the reduced complexity mousetraps shown below are intended to point out the logical flaw in the intelligent design argument. They're not intended as an analogy of how evolution works. Well, what does that mean? You know, if they're not intended as an analogy of how evolution works, then what's the point? And what is this logical flaw in the intelligent design argument? Well, it turns out the logical flaw, as he saw it, was that I had pictured a mousetrap with 5 parts. He could make one with fewer, and therefore you can make simpler mousetraps than I had pictured. And my response to that is, no kidding. You know, you can make mousetraps any of a number of ways. My family, sometimes we use glue traps, you know. My kids have a game called Mousetrap with a lot of different parts. As a matter of fact, I had said the same thing in Darwin's Black Box, in the book. I had said we need to distinguish between a physical precursor and a conceptual precursor. The trap described above is not the only system that can immobilize a mouse. On other occasions, my family has used a glue trap. In theory, at least, one could use a box propped open with a stick that could be tripped, or one can simply shoot the mouse with a BB gun. That'll show it. However, these are not physical precursors to the standard mousetrap, since they cannot be transformed step by Darwinian step into a trap with a base, hammer, spring, catch, and holding bar. The point is, we have a trap right here that we're trying to explain. Can we get to that by numerous successive slight modifications? Well, let's let's ask the question, using John McDonald's intermediates, can we do that? Are they numerous successive slight modifications, precursors to a type of mousetrap that he showed as the full mousetrap? And can you get there by a Darwinian process? Well, we'll go through and show that you can't, but let's look at something else on his website that should give us pause. He said, the first step in reducing the complexity of a mousetrap is to remove the catch. Okay. The hold down bar is then bent a little so that it will catch on the end of the hammer that protrudes out from the spring. This end of the hammer might need a little filing to make the action nice and delicate. Now, what's the problem with this? Well, we've got John McDonald, intelligent agent, re-engineering the trap to make it work. But if you use your intelligence to rearrange things, that is not a Darwinian process. Okay, well, let's look then. Let's start with the simplest mousetrap, as evolution would have to do, and see if we can go from one to the other by a random, numerous successive slight modifications. Here we start out with step one, the trap here, the one-piece mousetrap. And the first thing to say is that this is the strangest looking spring I've ever seen in my whole life. I have never seen anything like that. What's more, we can tell that it was purposely designed this way in order to act as a mousetrap. If these angles had been a little more oblique or acute, if the length of this thing was bigger or less big, this trap wouldn't work. Well, okay, you got to start somewhere. So let's give him that. But let's say that if intelligence has anything to do with it in any other step, then we don't have anything really relevant to Darwin's theory. And intelligence comes along right away. For example, here we go from 1 to 2. Okay, so we have a two-piece trap now with a spring and a platform. But you'll notice this is not the spring that was here. Okay, this particular arm of it has been bent by 90 degrees, and this part shortened by a considerable length. This arm here has been bent by 180 degrees and shortened considerably. So not only do we have an extra part, but we have had to re-engineer a second part. So this is just a little cartoon to show that we can't go directly from here to here. We have to have somebody engineering things in order to get to the final configuration. But we have to ask ourselves, wait a second, the spring here was in tension on itself. Why doesn't the spring here kind of spring and relax? What's keeping it under tension? It's not hitting against another part of itself again. Well, if you look real close, you'll notice here's a little staple here, and here's another little staple over here. If it weren't for those staples, the trap wouldn't work. They're keeping it under tension. Not only that, notice that the placement of the staples is very important. If this staple was over here, that one over here, it wouldn't work. So we have not gone from a one-piece to a two-piece mousetrap. We've gone from a one-piece to a four-piece mousetrap, which has been re-engineered in the process. So where did those staples come from? Did an angel bring them from heaven? Well, no. Darwinism cannot invoke angels bringing staples for mousetraps because the angels are on our side. Okay, we go from step 3 to step 4. This is the last one I'll show you here. Now we're not only adding a piece, the holding bar here, but we also have to rearrange the hammer here in order to lengthen it and give it a couple more bends and so on. Not only that, notice that the new piece is not just a flat metal bar. It's got this little curl on it, and it's hooked around this staple here. If it wasn't for that little curl, this whole trap would be useless. So not only do we have an extra part, we have re-engineering all along the way. And step 4 to step 5 I leave as an exercise for the audience. So the point is that we'll get to that. The point is that that intelligence saturates the whole series, and that if you can't even go from one simple mousetrap to another simple mousetrap without invoking intelligence, how much more unlikely is it to go from one complex molecular machine to another?